You are welcome to part 2 of this training. In part 1, I explained how to sample data. So you have your data set and you want to sample. I explained how to sample with replacement and how to sample without replacement. If you didn't watch the video, you can go back to my YouTube channel and watch the video. So for this video, I'm going to explain how to generate, this is the part of it, how to generate or how to simulate random numbers. If you want to simulate random numbers, you have to know the distribution you are simulating from. You want to simulate from binomial distribution, Bernoulli, normal, uniform, Poisson, exponential. So you have to know the distribution you want to simulate from. Now, the distribution you will simulate from depends on the kind of data you want. If I want a data that can give me both negative, positive, then I can use the normal distribution, because the normal distribution moves from negative infinity to positive infinity. If I want to simulate from, I know the minimum, I know the maximum, and I want the numbers I want to simulate to be within that range, I can use the uniform. Let me, as I'm explaining, let me write an example. So whenever I want to simulate, you start with arrow. Arrow means random, then you write the name of the distribution. So I gave an example of uniform. So how to simulate from uniform. So you start with arrow, then you write the name of the distribution, which is, so for uniform, with arrow spells it as unif, UNIF, uniform, arrow unif. The first thing you write is the number of data you want. So let's say I want to simulate 10 numbers. Therefore, uniform, you state the lowest. The lowest should be -3. Then you state the highest. The highest should be 8. So what I'm telling arrow is to give me numbers, 10 numbers from -8, -3 to 8. So that's it. It won't go below -3 and it won't go above 8. So when you want to simulate numbers from the uniform distribution, it means you know the lowest, you know the highest, and you know the number of data you want arrow to simulate from it. If I want numbers from negative infinity to positive infinity, I can use the normal distribution. So let me use normal. I use arrow norm, arrow random, norm, normal. So if you are using normal distribution, first thing you state is the number of data you want. I want 10 numbers. Then you state the mean of distribution. So the mean tells you the center point, where all the numbers arrow is going to generate to center at. I want it to center around 80. Then the next thing is standard deviation. If the standard deviation is large, it means the values will be far from each other. But if the standard deviation is small, the values will be close to each other and will be close to 80. So let me start with small standard deviation. So let me use 0.6. You will see they will be close to 80. I see they are all close to 80. But if I use a large standard deviation, so let's say I use 20, they'll be far from each other. If I increase the standard deviation, they'll be far from each other. So as you increase the standard deviation, it means you are increasing the dispersion within data set, and that's how they'll be far from each other. So I've been able to simulate from the normal distribution. Now, if I want 0, 1, 0, 1, just 0 and 1, I want to simulate binary numbers, binary. What will I use? I can use the binomial. Binomial is not just for simulating indicator variables, binary numbers. No, not just that. But let's start with that. So you start with arrow binom. So arrow, always start with arrow. Then the first thing you write the number of data. I want to simulate 10. Then the size you put 1 if you want indicator variable 1. Then the probability, I can put maybe 0.8 or let me say 0.7. So the probability is between, choose number between 0 and 1. That's it. So I've been able to simulate indicator variables. But we can use the binomial distribution to simulate other kind of numbers. So when do we use the binomial? If you want to talk about number of success, the number of success cannot be more than n, more than Let me show you what I mean. Cannot be more than the size. So if you write arrow binom, you are supposed to put 3 numbers. The first number is the number of data you want to simulate. Let's say I want to simulate 15. Then the next thing you do is size. The size means arrow will choose number from 0 to the size. That's the number you're going to write next. So if I choose 4, it means I'm telling arrow simulate between 0 and 4. So 0 and 4. Then I'll tell arrow the probability of success. So use probability of success of 6.65. So this is it. I arrow simulated and 0 didn't come out. Sometimes 0 comes out, sometimes 0 doesn't come out. Remember, if you want to get the same result anytime you simulate or select a sample, you must set seed. If I repeat this, if I run this code again, I'll get a different result. The reason because I didn't set seed. But if I set my seed, let's set seed 3, I explained set seed in the part 1 of this particular topic. So if I set seed, I will get the same result. So you set seed to get the same result. So I've explained how to simulate from the uniform, how to simulate from the normal, how to simulate from the binomial. So you can simulate from other distribution. We have the Poisson. If you are using Poisson, you arrow poise. You can simulate from exponential, arrow expo, ESP. So that's how, if you want, whenever you want to simulate for any distribution, you start with arrow and type the name of the distribution. The type of distribution you use depends on the kind of data you want. You want an indicator variable, you use binomial, 0, the size should be 1. Stopping at 1 means you are starting from 0 and you end at 1. But if you change 1 to 4, it means you are telling arrow, so let's start from 0 and end at 4. If you know the lowest, you know the highest, you can use the uniform. You can use normal if you know the mean, and you know the dispersion within the data set, how you want the data set to vary from each other. And you can also simulate from other distributions. We'll be using these codes for this training. Don't forget to always set seed to replicate your results. I'm going to stop here for today. If you have any question, do well to send to my email. Don't forget to subscribe to this YouTube channel. There are a lot of things to learn. I'm also teaching statistics. I'll be teaching distribution theory on this channel. I'll be teaching statistical inference and other topics. If you have questions, you send to my email. Also like this video and share. Thank you. See you.